Hi, this is Javin Kharot, a chemical engineer by profession, going to continue our today's lecture, Reactor in the Chemical Industries. Now, what is that? Chemical reactor play a crucial role in chemical industries where various chemical reactions take place to produce desired product. The reactor come in different types and have specific function based on requirement of the reaction. Understand the different type of reactor and their function essential chemical engineer and operator in industries optimize the reaction process and improve efficiency of production. Now batch reactor are often most common type of reactor used in chemical industries. Batch reactor, all the reactant are placed reactor vessel. Reaction allowed occur under control condition. The reaction proceed until desired conversion is achieved, after which product is removed from reactor. Batch reactor are used small scale production when reaction time relatively short. They are versatile and allow easy control reaction parameter, temperature, pressure and mixing. Now continuous stir tank reactor. Continuous stir tank reactor are another widely used type of reactor. Chemical industries. CSTR reactant are continuous fed into reactor. The product is continuous removed, maintain steady state. Reactor content are continuously mixed. Ensure uniform reaction condition throughout the reactor. CSTR are particular useful reaction that require high degree mixing and heat transfer. They are often used large scale production. Continuous reactant is necessary to achieve high pressure. CSTR, one of more fluid reagent, they are introduced. Tank reactor, which are typically stirred the impeller and ensure proper mixing of the reactor while reactor effluent is removed, dividing volume of the tank and average volumetric flow rate through tank give space time or time required process one reactor volume of fluid. Using chemical kinetic reaction expected the percent completion calculated some important aspect CSTR production rate. A steady state mass flow rate must equal mass flow rate out, otherwise tank overflow, go empty, transmit state, while reactor is transmit state. Model equation derive differential mass and energy balance. The reaction proceed, reaction rate associate final concentration. The concentration assume homogeneous throughout the reactor. Often economical beneficial operate several CSTR in series allow CSTR operate higher reagent concentration and therefore high reaction rate. In the case, size of reactor may vary order to minimize total capital investment required to implement the process. Now demonstrate infinite number of infinitely small CSTR operating in series would equivalent PFR. The behavior of the CSTR is often appropriate, molded and continuous, ideally stir tank reactor. All calculation performed assume perfect mixing. If the residence time 5 to 10 time mixing time, the approximation is considered valid engineering purpose. Now CSTR model often used simplified engineering calculation can be used to describe research reactor. In practice only approach particular industrial size reactor which mixing time may vary large. A loop reactor is hybrid type catalyst reactor. Physical resemble tubular reactor. Output operate CSTR. Reaction mixture circulate. Loop of tube. Surrounded jacket and cooling heating. There are continuous flow. Starting material product out. Now plug flow reactor. Plug flow reactor are designed allow reactant flow through reactor continuous manner without back mixing. The reactant enter reactor one end and flow through reactor in a plug-like fashion. With minimum mixing, transfer the flow direction and result high degree axial mixing while maintain a low level radial mixing. Plug flow reactor are well suited for reaction, require long resistance time and high degree of conversion. Their use, the process were maintain good fluid dynamic, critical achieve high product yield. Idealized plug flow reactor model assume axial mixing any element of the fluid traveling. The reactor doesn't mix fluid upstream and downstream. It implied term plug flow. Reagent introduce PFR location, the reactor and other inlet. The higher efficiency obtained, size and cost of PFR may be reduced. PFR has high theoretical efficiency, CSTR same volume, that is given same space-time, reaction produce and proceed higher percentage completion PFR in CSTR. They are not always true for reversible reaction. The chemical reaction of industrial interest, impossible reaction, to produce 100% completion. The rate of reaction decrease, reactant are consumed point where system reaches dynamic equilibrium. The equilibrium point and most system 100% complete. A separation process, such distillation, follow chemical reactor, order to separate any remaining reagent and byproduct desired product. This reagent may sometimes reuse beginning process, such harbor process. Very large reactor would necessarily approach equilibrium. Chemical engineer choose to separate the partially reacted mixture, recycle leftover reactant. Now, under the laminar flow condition, assumption plug flow highly inaccurate as fluid traveling through center of tube move much faster. The fluid wall, the continuous oscillation baffled reactor achieve through mixing, combination, fluid oscillation and orifice baffle allowed at plug flow approximate under laminar flow condition. Now packed bed reactor. Packed bed reactor are the vessel filled with catalyst particle, other solid material that serve support for reaction. The reactant flow through the packed bed allow reaction to occur surface catalyst material. Packed bed reactor are useful catalyst reaction where catalysts play crucible role promoting reaction, high surface area, reactant and catalyst leading reaction rate selectively. Packed bed reactor are commonly used industrial process, fuel processing, petrochemical production and wastewater treatment. Now fluidized bed reactor. Fluidized bed reactor are suspended solid particle, gas or liquid, flow creating fluidized bed particle. Fluidization bed allow excellent mixing of reactant and heat transfer, making fluidized bed reactor highly efficient. Variety of reaction, the constant movement of the particle, fluidized bed prevent hot spot and ensure uniform reaction condition throughout the reactor. Fluidized bed reactor are commonly used process that involve catalyst reaction, gas solid reaction and thermal treatment. They are high mass and heat transfer rate which contribute improved reaction efficiency. Now chemical reactor are essential device chemical industries carrying out various reactions, produce desired product, understand the different type of reactor, their function, chemical engineer and operator, optimize reaction process, improve efficiency production and achieve high quality product where batch reactor, small scale production, constant stir tank reactor, continuous operation, plug flow reactor, long residence time reaction, packed bed reactor, catalytic reaction and fluidized bed reactor, excellent mixing, heat transfer. Each type of reactor unique advantage and application. By choosing right type of reactor, specific reaction, industry's professional enjoy the process of their process, achieve their production goal. Now batch reactor model are idealized model. To estimate most important process variable different chemical reactor are batch reactor model, continuous stir tank reactor, plug flow model, many type, real type reactor molded, the combination of basic type. They are basic type include residence time, volume, temperature, pressure, concentration of chemicals ratios C1 up to Cn concentration and heat transfer coefficient. tubular reactor can often pack back this type of tube and channel contain particle and pellet with a solid catalyst, reactant and liquid and gas phase pump through catalyst bed. A chemical reactor may fluidize bed. Chemical reaction occurring reactor may exothermic, meaning giving off heat, endothermic, meaning absorbing heat. A tank reactor may have cooling and heating jacket, cooling and heating coil wrapped around outside of vessel, cool down and heat of content by tubular reactor, designed like heat exchanger in the reaction, strongly exothermic like furnace and reaction strongly endothermic. Semi-batch reactor. Semi-batch reactor operate both continuous batch input and output. Now fermented, example loaded with batch, medium and micro constantly produce carbon dioxide, remove continuously. So reacting gas with liquid is very difficult because large volume of gas, equal mass of liquid and overcome problem, continuous feed, gas bubble through batch of liquid, general semi-batch operation, chemical reactant loaded into the reactor, second chemical add slowly or product with the result, phase change continuously, remove example, gas form by reaction, solid precipitate out and hydrophobic product form aqueous solution. Now catalytic reactor. Catalytic reactor are implemented plug flow reactor that analysis require complicated treatment. Rate of catalyst reaction is proportional amount catalyst reagent content and reagent proportional exposed area. Efficiency of diffusion reagent and product out. Efficiency of mixing, perfect mixing cannot be assumed. Further, catalyst reaction pathway occur in multiple steps. Intermediate are chemical bound and catalyst and chemical binding. Catalyst also chemical reaction may affect kinetic chemical reaction display falsified the kinetic that apparent kinetic different from actual chemical kinetic due to physical transforming effect. The behavior catalyst is considered particular high temperature petrochemical process. Catalysts are deactivated by process sintering, coking and poisoning. Common example chemical reactor. Catalyst converter process toxic component automobile excuse. However, most petrochemical reactor catalyst and responsible most industrial chemical production with extreme high volume example into sulfuric acid, ammonia, benzene, toluene, ethyl benzene, xylene and fluid catalytic cracking. Various configurations are possible homogeneous catalytic reactor. Okay guys, this is up to our today's topic, reactor in the chemical industries. I hope you get knowledge after watching this video. Next Friday, we have considered some another chemical engineering topics. Till then, goodbye. Do take good care of yourself.